Alright, tangent lines. This is mostly review. This is stuff we've talked about before, so we're going to go through this relatively quickly. Remember that the derivative of a tangent line, or the slope of a tangent line at a certain point, is just the derivative, right? So if you can find that derivative, you already have the slope, and if they give you an x value, you could plug it in and get the y value, or sometimes they just give you the y value. So that's your x1, your y1, and then the derivative gives you the slope. So that's all you got to do to find the tangent line, and we use point slope form here because it's the easiest to plug into. We don't have to convert it to any other form. We could just leave it in that unless they ask for it in a specific form, but usually this is just fine. So let's talk about this. A couple things. First off, this is my x1 and this is my y1. That's beautiful. I'm 2/3 of the way done with this problem. All I need now is the derivative, and I need the derivative at x1. So another way of thinking of this is f prime of x1. That's what you need. So first thing we're going to do is we're going to just find f prime of x. Well, f prime of just x is just 2x. So what's f prime of x1? My x1 is 2. It's 2 times 2, so it's 4. So my equation, my line is going to be y minus my y1, we said was 5, equals my slope at x1 is 4. X minus x1 is 2. Easy. Now, if they asked you for the y-intercept or something, then you're going to have to get this in y-intercept form. But really, that's generally all you need to do. Let's go to the next page. Okay, I got a couple equations here for you to try out. Again, I give you the x1 and the y1 here. I want you to just go ahead and try example 2 here on your own. Give it a shot, and then pause the video, work on it, and then unpause it when you're ready to check your work. Okay, again, they give you the x1 and the y1, so that's easy. So that's why I put a minus 4 here and a plus 3 here because I'm going to do a double negative, so that's why that's a plus 3. Then I just take the derivative of the problem, and I get 2x plus 2, plug in a negative 3, and I get negative 4 for my slope. So I plug in the negative 4 there. That's all there is to it. What if they give you a problem like this where they only give you one x value? So you have x1, but what about y1? Well, y1 is really just equal to f of x1, not f prime of x1, just f of x1. So you just plug it in. What's 2 cubed? Well, 2 cubed is 8. So we just found the y1. All right, so again, we're going to use point slope form. Y minus y1 equals f prime of x1 is our slope times x minus x1. Now, we still need to find the derivative of x. So the derivative of x is 3x squared. And then we specifically need the derivative of x1, which is 2. And so we get 3 times 2 squared. That's 2 squared is 4. 4 times 3 is 12. So let's plug it in. Y minus, we found the y1 was 8. We found that the slope at x equals 2 is 12. And x minus our original x1 is 2. That's it. Let's go to the next page. Okay, similar problem. I want you to try it on your own. Again, pause the video, work it out, then unpause it when you're ready to check your work. Okay, hopefully the first thing you notice, they only gave you the x1, so you're going to have to plug that in to get your y1. When you do, you get negative 18. Then you're going to need to take the derivative and plug in a negative 2 into the derivative to get the slope. So you got y minus negative 18, which is y plus 18, equals 17, x minus negative 2, which is x plus 2. So there it is. I'll see you guys on the next video.